All right. So here we are doing FreeCodeCamp Legacy Python for everybody, intermediate expressions. All right. It's hurricane day today down here where I am. Also, what else is going on? Also, it's the first day back, so we're going to go for however many weeks, 6 days a week. Let's do it. There's the logo right there. Also, this one's broken up into the video, and we've got two other exercises right here, as well as this. We'll go over this one and this one. We'll go over this in another video, this in another video, and then we'll do this at the very end. All right, so let's get to it. Hold on. I got my notes. Yeah, I do. Let's get to it.
So welcome back. We're now going to talk about expressions. Expressions are a little more complex calculations that we can sort of do on the right-hand side of an assignment statement.
All right, let's start typing. Let's start off with expressions down here. Let's do expressions. All right. And then we'll start off with numeric expressions. So numeric expressions. Let's see what it says. Because of the lack, because of the lack of mathematical symbols on computer keyboards, we use computer speak, all right, to express the classic math operations. All right. Asterisk is multiplication. We knew this. Asterisk, yes, is multiplication. And then we have exponentiation, raised to a power. Looks different than in math. I guess it's because they're talking about it would be like let's say 2 to the 10th power would be like this. I think that's what they mean, but I don't know, honestly. Huh? Maybe it's like that. 2 to the 10th power like that. Maybe that's what they're talking about. Anyway, whatever the case may be, we'll figure it out later. So let's go.
So one of the things about expressions is operators. And the operators in computer programming are often very much the same as the mathematical operators. But we don't have all the fancy characters that we have in mathematics. And so we have to choose what's on the keyboard. And then we really go back to the 1960s and 1970s. And then we used what was on the keyboard in the 1960s and the 1970s to make these operators. So plus is addition, minus is subtraction. We don't have a times sign or a dot in the middle, so we use the asterisk as multiplication. Division, we can't put two things over top of each other, so we use slash for division. Raising to the power, because it didn't have little characters back then, is star star, which is raising to the power. And then remainder. Remainder is when you do integer division, it's also called the modulo operator. It's the remainder, not the quotient. Now I've got a picture of that coming.
Let's type those in while we're at it. I mean, I know them, but good practice for anybody that's watching that doesn't know them. Operators. Operator. Let's go down and see where the tab goes at. Let's do 2 tabs over. All right. And then we'll have operation. So we'll do plus, addition, minus, subtraction. We've got the star, that's going to be multiplication, that's not what I said. Multiplication, there we go. Division, like this. Division, and then we've got star star, power, and then we've got the modulo, and that's going to be remainder. And let's call it modulo while we're at it. Modulo. Boom. Bring it back one. There we go. right, so that should be good. Let's get back to it.
No.
All right, so let's look at this first before he gets to it. So xx equals 2. We're making these two x's equal 2, right? Whenever we say something like print xx, it's going to be 2. But after this, we're saying xx now equals xx plus 2. So it would be the 2 that it was before plus another 2. So now xx equals 4. So when we do print xx, we can see 4 right here. All right, yy equals 440 times 12, so it's going to be 5280 right here when we print it. ZZ is YY divided by 1,000, so it's going to be, it's going to put a decimal right here, and it's going to be 5.28, just like that, because that's what whatever this is, 5280 divided by 1,000 is, okay? We got JJ equals 23. If we want K, we can say KK equals JJ modulo 5, so it's going to, what it's going to do? It's going to say 23 divided by 5. It would be like 4 point whatever, but it's 4 times 5 is 20, so the remainder would be 3. So when we print KK, it's going to give us 3, right? Because the remainder of 23 divided by 5 is 3, right? And then we've got print 4 to the third power. It's going to give us 64. This right here, we'll see what he's talking about.
So here's a whole series of little examples of this, right? So we've already seen, the plus, x equals x plus 1. Keep remembering that these assignments are arrows, basically. Arrow, arrow, they have a direction. Multiplication.
Every time he says arrow, I mean, I get it, but every time he says arrow, he means that this 2 is now what xx is, right? So xx is now 2. So the 2 is now inside of the xx variable, something like that. I think that's what he's trying to say. 440
times 12, dividing this by, that's division over 1,000, 5.28. Here we're going to put 23 into JJ, and then we're going to do modulo. So that says, take 23, divide it by 5, and give me back the remainder and put it in KK. So this is the expression that evaluates like this. Take 23, divide 5 into 23, 4, remainder 3. The 3 is what comes back up here. Okay, and so that is...
Yeah, so this is just like old elementary division. So 5 divided by 23, 5 divided by 2 is nothing, so we move it over 1. 5 divided by 23, closest thing would be 20, so we would say 5, so we would say, pardon me, it would be 4, so we would say 5 times 4 equals 20. 23 minus 20 is 3, so the remainder would be 3, just like the old days.
The remainder. It's also called modulo operator. It turns out that for things like picking a random number and then taking the modulo of 52 is a way to pick a card randomly. So this modulo operator is actually, especially in games and other things, super useful. So that's the various operators. It's important to know.
All right, let's do this. And I'm sure it's just talking about PIMDOS right now, but we'll write that down anyway. All right. So let's go to the end, come down here, and this says order of evaluation. Order of evaluation. All right. When we string operators together, Python must know which one to do first. All right. This is called, I guess it's not PIMDOS, Operator Precedence. All right, precedence. Okay. And then what are we going to get here? Which operator takes precedence, I don't know, over the others? I guess the 5 to the 6th power, I guess the power operator, and then this one, but we'll see what he says in just a second.
Know which of these operators goes first. That's called operator precedence. Now normally we put parentheses in, like, so if I put the parentheses in here, I'd say this goes first, parenthesis, then this goes first. Oh, actually not that one. Whoops, got that one wrong. This happens first, this happens, then this happens. Okay? And so But it's important for us to be able to know, if there were no parentheses, the order in which these things will happen. So the way things work in terms of operator precedence is parentheses
All
are
right,
the most...
let's go. Let's type it out. What does that say? Operator precedence rules, okay? Operator precedence rules, okay? So highest precedence rule to lowest precedence rule. Oops. All right, so we'll do parentheses. Parentheses are always respected. Okay. Exponentiation. So it is PIMDOS. It's totally PIMDOS. All right, let's write it. Let's write it down anyway. Raise to a power. It's totally PIMDOS. Multiplication, division, remainder. Right? I'm sure it's in that order too, but we'll see at some point. Addition and subtraction. And then it's going to go from left to right. Left to right. All right, so I guess actually it's like if there was a division first and then a remainder and then a multiplication and then another division, it'd probably start with the first division, then the remainder, then the multiplication, then to the last division, according to left to right. But we'll see if that's what he says.
Most important thing, followed by raising to the power, all else being equal. Multiplication and division are all both equal. And then addition, and then within, it's adding left to right. So let's see an example of how this works. And so if we take 1 plus 2 to raise to the 3 power.
All right, let's look at it before he says something. So yeah, this is going to do the powers, right? The powers, which is going to give us 8. 2 times 2 times 2, so 4 times 2 is 8. Divided, so that's going to be divided by 4, which is going to give us 2, and then we're going to do the multiplication. So it is, so since this division is before this division, is before this multiplication, this one's first, all right? And then we add them together and do 1.
Divided by 4 times 5. And we print out what comes out of this. So the way I did this when I was taking exams back many, many years ago when I was first in computer science, is I'd write it all down and I'd look for the highest precedence thing. Now parentheses would make this easy, but exponentiation is the first one. So that means we're going to take this, and that's going to be 8. 2 to the 3rd power, 2 times 2 times 2, 2 cubed is 8. Then what I would do is I rewrite the whole thing with the 8 there. And now I look across, and I'm looking for multiplications, because the power's been done, the multiplication is what I'm looking for next. And then there is both multiplication and division. They're equal. They're at the same level. And so what happens is they're done left to right. 8 divided by 4 happens before 4 times 5. And so the fact that it's not 4 times 5, but instead 8 times 4 is because of the left to right rule. So then this gets rewritten to be 2. 1 plus 2 times 5. And this one, multiplication, is the top one. So that does this next. 2 times 5 becomes 10. I rewrite it again. And then 1 plus 10, addition, is the lowest thing. And that's how we end up with 11. And so that's how I would do these problems if I ever saw the problem on an exam. And it's a fun problem to put on exams because there is one and only one answer, and every programming class has usually at least one slide about this stuff. So like I said, the rules go...
All right, operator precedence. What? Okay, yeah, so let's write this down. Let's grab this, copy it, drop it down, 2, drop it here, and then let's say type. Remember the rules top to bottom. Remember the rules. Go from top to bottom. Gotcha. When writing code, use parentheses, right? When writing code, we're going to keep mathematical expressions simple enough that they are easy to understand. All right, good. Now, one more thing. Break long series of mathematical operations up to make them more clear. All right. Break long series. Okay, cool. Break long series of mathematical operations to make them more clear. All right. We'll
top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about.
All right. Let's write some more stuff down. And he'll talk about it for 5 seconds. What does type mean? Let's type that down. What does type mean? Question. All right. In Python variables, literals, and constants, what? In Python, comma, in Python, variables, literals, and constants have a type, all right? Python knows the difference between an integer number and a string. All right. For example, plus means addition. Hold on. Addition. If something is a number, and concatenate if something is a string, right? So if you've never seen the word concatenate before, yeah, it means put together. But what it really means is, like, let's say, yeah, like right here, we've got DDD, the, what is the thing called? The variable DDD equals 1 plus 4. When we print DDD, it's going to equal 5. So EEE is going to be hello with a space plus there. So this is called concatenation right here, because when we print EEE, it's going to have hello space, and there like that, right? So this is concatenation, while this is addition, right? And it knows the difference when this stuff is happening. So let's keep going.
About variables and computing values to put inside variables, but the one thing you've kind of also, maybe you noticed it as we go by, is we have different kinds of data. We call it type. Is this of type integer? Is this of type floating point number? Is it of type string? What is going on here? And Python is pretty smart about various kinds of types of data. And so, you know, we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate two strings. This is hello blank plus there. And plus looks here, says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those two things together so it becomes another string that gets assigned into EE, and it's hello space there. The plus doesn't add the space. I added the space by putting it right there.
Exactly.
And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us in trouble.
All right. Hold on there, Dr. C. We got to type this down. All right, let's get this down. Type matters. Type matters. All right, and it does, actually. So let's see. Let's go here. Python knows what type everything is. Okay? some operators are prohibited. I wonder which ones. We'll see. We cannot add 1 to a string. What does that mean? We can ask Python what type something is by using the type function. All right. So yeah, we can't add 1 to a string. Like let's say we've got string 20 plus the number 1. It's not going to make it 21. It's going to make it 20, and then it's going to make it 201. It's going to make it the string 201. It's going to have the 20, and then it's going to add the 1 to it. I'm pretty sure that's what happens, but actually maybe nothing. Oh, look here. Okay, so never mind. Let's look at these. Let's look at this example. So we've got EE equals hello there, right? So now we're changing it to hello there plus 1. Then we've got traceback most recent last call. This thing right here. File line 1, I guess that's the name of the file. In module type error, can't convert int object to string implicitly. So yeah, this is just going to give us an error. It's not even going to make it like hello there 1 or anything like that. So yeah, let's check out what he says.
So here we have EEE, which is hello there, because we've concatenated these 2 strings together. And now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says, I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I've become confused. So your program stops running and you say, here's where I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but if you read carefully and you don't get too stuck on too much stuff, line 1, that tells us something. In module type error, can't convert int object to stir implicitly. So that's an integer right there, and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So there turns out that there is, inside Python, a built-in function called type, T-Y-P-E. So we can pass into type. So the syntax is calling a built-in function named type, parenthesis is the parameter that we're passing to it. We're saying, hey, hello, tell me something about the type of the variable EEEE. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking Python through the type function what the type of either a variable or a constant is. And there are even several types of numbers.
All right, let's get some more
numbers, and we'll even see.
Let's type some more. All right, there it is. Here we go. What's it say? Several types of numbers. Let's do it. So, several types of numbers. All right. First one, numbers have 2 main types. All right. Integers are whole numbers. We know what whole numbers are. Although I didn't realize. Okay. Whoa. All right. Okay, let's get this. Emergency X. Bring this up. Okay, drop it down here. All right, now we're back at it. Whole numbers, and let's just say 1, -1, 100, blah, blah. All right. And then we've also got floating point numbers have decimal parts. So -1.1, 1.2, doesn't matter. 0.0 or whatever. And then 0.0. How about that? That looks fantastic, right? Now let's go here and let's say there are other number types. They are variations on float and integer. Take your word for it. Let's go. Let's go.
Booleans and others like later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, you know, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1, and what's the type of 1.0. You can also use a set of built-in functions.
Okay. Let's get to it. So what does this say? Type conversion? Type conversions. Type conversion. When we put an integer and floating point in an expression, the integer is implicitly converted to, implicitly converted to a float. When we put an integer and floating point in an expression, the integer is explicitly converted to a float. Okay, so it turns into a float if there's a float involved. So it doesn't turn the float into an integer. So we can control this with the built-in functions int and float. All right. So this would turn it into a float, and this would turn it into an int. So if we did like right here, print. Let's find out if we can do int. No, we don't have an int over here. Well, whatever. Print float 99 plus 100, right? So it would give us 199 because it would be the 199.0 because this is a float. This will be converted to 99.0. And then if you add an integer to a float, it keeps it as a float. This one's going to be class integer. If we do float I, it's going to give us 42.0. And then we can see it gives us the class of float. All right.
Like float and int to convert from one to another. And so this basically says, I want to convert, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before it can finish the plus, it turns this into a 99.0. The difference between 99 as an integer and 99.0 is that it's a floating point number, and that actually turns this computation, as it looks to the left and looks to the right, says, oh, I've got a floating point number on one side and integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has a 42, also an integer, and then give me back a floating point. So that'll be 42.0. Pass that into f. We print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0.
I wonder if are these like plants? Are these like government plants that he's throwing all these XXXs and 420s into the thing? Is this like government plant? Like, you know, like I know you could have picked other numbers, bro. Are they like telling this guy, you know, indoctrinate these people with weed and XXX? You know what I'm saying? Whatever. I don't believe that's one of the reasons I dropped out of college. This is an aside. That's one of the main reasons I dropped out of college, because I was smelling all of the indoctrination. Like while I was in there, I was just like, this is just so. It just kept getting every year we get more and more cringy. how disgustingly indoctrinated they were trying to make us. And they made plenty of people. They made plenty of them, actually. Integer division. I mean, just look at any like lawyer or judge or doctor. They're deeply indoctrinated into the system. Integer division produce. This guy too. I mean, you see him doing it yourself. Produces a floating point result. All right. So integer division produces a floating point result. So if we say 10 divided by 2, it's going to give us 5.0. 9 divided by 2 will give us 4.5. 99 divided by 100 will give us 0.99, and so on and so forth. And then integers divided by integers, same thing, right? And this was different in Python 2x, but we're not going to be able to.
Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. This is a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable, and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. And this, 10 over 2 could be 5, but 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all. It truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so...
Thank you, Dr. Chuck. Let's go to the next one. String conversions. String conversions. That's what it says, all right? So string conversions. So we can also use int, the int function and float functions, the int and float functions to convert between strings and integers. And then what does this say? We will get an error if the string does not contain numeric characters. All right, let's see what he's got.
So we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string.
Let's go through it the fast non-boomer way first. So sval equals 1, 2, 3, right? So whenever we check the type of sval, it's going to give us a string, yes. Print sval plus 1, like we saw before. A string plus an integer is going to give us this error, right? So ival equals int sval, right? So now when we check the type of ival, it's going to be int. So it's this string right here into this int function and turned it into an integer, right? So when we say ival plus 1, it's going to give us 1, 2, 4, because 1, 2, 3 plus 4 is cool, and this ival is an integer, so an integer plus an integer equals another integer. So now we've got NSV Bob, hello Bob right here, and now NIV equals int NSV. We can't do it because there's no numbers in this. This is all letters, and it has to be numeric characters, right here. So now let's hear Dr. C say it.
That has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says, can't convert into string, so that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now add 1 to it and get 124. And so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're going to end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters, so that's going to cause this to fail.
All right. Let's see what this next part is before Dr. C gets into it. User input. Let's do that. User input. So we can instruct Python to pause and read data from the user using the input function. All right. We can instruct Python to pause and read data from the user using the input function. Okay. The input function returns a string. All right, let's see what he says, because I don't really know what he's talking about. Name input. Who are you? Print welcome name. Welcome. Who are you? What? Oh. What? All right, let's see what he's talking about.
The thing that we're going to do with variables is, just like the print function takes something, a list of things, in this case, a string, comma, a variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before output. Input is a built-in function, and we pass to it a prompt, a string of text that's going to be printed out for the user, and then it stops and waits. So it says, who are you? And then right here it just sits, waiting for us to type something. So we type blah, 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 and then hit the enter key. Right? We hit the enter key, and then this text ends up in this variable. So this is an assignment statement that Chuck is the result of the input call, gets copied into the NAM variable.
All right. Okay. So what he didn't say, I don't know if he's going to say it or not, but regardless, this is because it's going to read both of these things before it does it, right? So it comes here and says, welcome. Okay, so welcome, what's the next part? And then it's this. It says, okay, we got to do something here. So before it prints out welcome, it's going to print out who are you, because the input is who are you right here with a space after it, right? And then so we're going to enter Chuck afterwards. I don't know where we enter it. Hopefully we'll see. But once it's entered, then it's going to come back, and now it's going to print welcome space. Here's the space right here. I think there's a space right there. And then Chuck after that. We'll see if that's what happens.
So let's do that again. It's evaluating an assignment statement. Remember, it's kind of this way, or you can think of it as just do this right side first. It writes this out, writes that out, then it waits, wait, until we hit the enter, and takes this Chuck, and that becomes the result of this input, which is then assigned into.
Okay, so let's say we've got the command line up, right? Let's say this is the command line and it has the little 3 chevrons. And we just said print welcome this. So on the next line, it's going to do who are you, question mark. And then it's going to have the little blinking underscore right there, or whatever it is. Or maybe it's the blinking rectangle, and then it will say type in Chuck or whatever, and then press enter, and then on the next line down, I don't know if it's chevrons or whatever, it'll say welcome Chuck. We'll see it at some point. Hopefully we'll see it.
And AM. Now then we go sequentially to the next line. It prints out welcome, comma, NA, contents of the variable NAM. Now this comma here actually does put the space in here automatically, so it says welcome space Chuck.
Okay, so there's no space here.
Space in Chuck, just
I mean, there's no space in welcome. That's what I was saying. So yeah, it puts the space there automatically.
CHUCK. And so print can take more than one thing separated by commas. As a matter of fact, print can have, a whole bunch. Oops, come back. Print can have comma, 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 parentheses, as many as you like. Everything you've seen up to now is kind of one thing in the print, but that doesn't mean that print only can do one thing. So I've talked about variables, we talked about constants, we've talked about input, we've talked about output.
Yes, we have. Let's do this before you keep talking. We still got 5 minutes, which means like 10 minutes of writing. All right, let's do it. So let's see. Converting user input. Converting user input. So if we want to read a number from the user, we must convert it from a string to a number using a type conversion func. Oh, come on. I'll have to edit that. Edit. Function. Talk about indoctrination. Later, we will deal with bad input data. All right. So if we want to read a number from the user, we must convert it from a string to a number using a type conversion function. Okay, so anything that comes into the input, regardless, the input is going to be a string, no matter what we put in there, no matter if it's numbers, letters, whatever, right? So the input is going to be the string, where say Europe floor 1 or whatever, 10, who knows, or 0. How about that? And then US floor is going to be int input plus 1. Okay, so if it was 0 plus 1, the US floor would be 1. So print US floor, US floor. So Europe floor, question mark, 0, US floor is going to be 1. Okay, there we go.
And now it is time to write our first meaningful program. And so this program has to do with those of you who have traveled internationally. If you traveled to the United States and you traveled outside the United States, you notice that there is an elevator convention that is different inside the United States. In the United States, walk in the ground floor in the elevator, that's 1. And if you walk in the ground floor in Europe or many other places in the world, and the elevator is 0. So we have written a small app that we're going to put on the App Store and get wealthy with called Elevator Floor Conversion App. And it's going to ask us, we're in Europe and we're lost, and you say, well, what floor would this be if I was in the United States of America? And so we have to read the floor that we are at.
Do you really need that, though? I mean, it's going to have the buttons, and they're going to tell you go to floor 5. They're not going to say, go to floor US 5. Oh, come on,
in Europe, and then we're going to convert it to a US floor, and then we're going to print it out. This is very silly, but it is a pure essential program that has input, does some kind of task on that input, and then produces some output, which is useful for some value of useful. Okay? So let's take a look at how we combine everything that we learned in this lecture, input, processing, and output. It's a 3-line program, but it's sort of the beginning of something that programs do. Okay, you're going to do lots of programs that do this. So
yes.
Here we go. Program starts. We do the input side effect. It prints out this and then waits. We type in 0. That comes back here. And the 0, which is a string. Input gives you back a string.
Yes.
It doesn't give you back a number.
Yes.
It's a little different in Python 2, but in Python 3, input gives you a string. So quote 0 quote, which is what we typed here. We didn't type the quotes. It's a string. Gets stored in the imp variable. Then we move to the next statement. And on this right-hand side, we convert that string variable to an integer, so that becomes the integer 0. We add 1 to it, and then that becomes 1, and then we assign that into USF. I've named this variable United States floor, right? So imp is the input, and USF, that's mnemonic. It doesn't know anything about elevators. It's just I picked a variable that was quite friendly. And so at this point, USF has the United States floor that's equivalent to the European floor, and then I just fall down and I do a print statement. Print out US floor, comma, that's this space right here, and then whatever the contents of the US floor variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European numbering scheme. Wait, actually no, I got that wrong.
Yeah.
Hang on. Let me clear this.
We got you, Dr. C.
I wasn't thinking clearly. I could type in 4 and it would give me back 5. I could type in 6 and it would give me back 7.
Very true.
See, I'm confused. Haven't been in Europe in a couple of months, and so I forgot all about the floor.
Couple of months. How about a couple of my whole life? Not knocking you Europeans, but you know, why travel? I mean, that's anyway. Whatever. I mean, if you want to come to the USA, come on over. But I am not going to the old world. I'm sure it's nice. I mean, unless I get $1 billion and I get to go to party in Ibiza. But whatever, let's go.
Now, this is a super simple program. Not super useful, but you get the idea that we're going to pull some data in. We're going to do some intelligent thing. Soon this will be hundreds of lines of code instead of one line of code. And then we're going to present the results to our user.
True.
Now, another element.
Okay, comments. We know comments, but if you don't know comments, let's write about comments. Comments in Python. All right. Anything after a hashtag is ignored by Python. I think it's only on one line though. Why comment? Why comment? Describe what is going to happen in a sequence of code. Document who wrote the code or other ancillary information. What's ancillary? Other related information? I guess ancillary is related. I don't want to look it up. Let's look it up. I don't want to look it up. Let's look it up. Okay. Give me a second. All right. I hope it doesn't say anything stupid. Ancillary. Anything stupid? Nope. Okay, good. Ancillary. Providing nothing stupid. All right, good. Providing necessary support to the primary activities or operations. That's good. All right, so it's related to or supporting stuff. All right. What else? I don't really know some. Also, we're going to turn off a line of code, perhaps only temporarily. Temporarily, right? So like if we want to check, anyway, if we don't want to use a piece of code right now at that moment, we can use the hashtag to just turn off that line, but it's only one line of code at a time. It's not like, I don't know if we can, I don't think that we can do like a whole block of code with just like this at the beginning and another at the end. I don't think that's how Python works, but let's go.
Of most any programming language is what's called a comment. A comment is a way for you to put in a program file some text that's to be ignored by Python or C or whatever language we happen to be using. In Python, comments start with a pound sign. So what you could do is put a pound sign anywhere in a line, and then after the pound sign, Python ignores everything after that pound sign. It can be the first character. So here's our
all right, let's look at this. All right. So here's the big word thing, all right? So this is the comment right here. It's the convention is to have a hashtag, a space, and then some words. So this is get the name of the file and open it. So it says name, we're having input, enter file. So it'll say enter file whenever we do the print or something like that. And then we're gonna do handle. Handle equals open, and then name R. Oof. Do we have open somewhere? Open name R. Anyway, we have to check it. We have to see what open does. I've never done that before. Then we've got another comment here, count word frequency, right? So counts equals this dictation dictionary thing that I don't think we made either. I think this just makes a new dictionary for line in handle words anyway. We're not going through that. And then we've got another one, find the most common word. All this does that. And then we've got all done right here.
Concept that we talk a lot about. We're not going to cover this. Remember what this does. This is counting how many letters. There's 16 thes, and there's in that file there were 6 2s or whatever it was. This is that code. We'll get back to this code. But what we've done here is I've added some comments that are really for human consumption. So this first paragraph is get the name of the file and open it. The second paragraph is count the word frequency. You know, maybe I should have said histogram here. Count the word frequency and assemble a histogram. And then here I'm putting this pound sign in, find the most common word, and then I'm all done. I print the stuff out, right? And so all I'm saying is comments are for people to read. Your next programmer or the person who's going to change it.
Yeah, basically we're just going to put this stuff in there. Comments, and we do it in Python. There's a lot of comments, a lot more in JavaScript if you've noticed so far. And we're just going to put a comment over every single little thing we do, just so down the line, somebody else can read it later. But when you go through actual Python, the comments are crap because it's still written by people that don't want to write anything. They just would rather write code, you know. But whatever, it is what it is. Let's go.
Your program after you're done with it, and they're nice, and you don't have to use any particularly weird syntax or variable naming conventions. You put a pound sign in, and you can write anything you want from that point forward. Okay, so we've talked a little bit about variables and types and mnemonics and how we would choose variable names and how expressions work and the various operators, converting between different types, printing, input, output, and comments. So that just kind of gets us...
Let's see if we wrote the summary last time. I think we avoided that. It's pretty big. Summary. Focus on the big picture. All right, so let's type this summary down anyway. All right. So summary. Summary. We'll remember the types, like integers and the other ones. Type. Integers and strings. All right. Reserved words, like reserved words. What were some like for, in, and, etc. All right, variables, mnemonic, variables, mnemonic. All right. And this means making variable names useful to understand. Useful for understanding. How about that? Understanding. We've got operators. We've got operators like plus, minus, times, etc. We've also got operator precedence, which is going to be PEMDAS, P, then exponents, then division. Wait, PEM division, also the modulo. And then we've also got addition, subtraction. All right. And then left to right. Left to right. All right. Integer division. Integer division returns floating point numbers. What else do we got? Conversion between types. Conversion between types. What do we got? Like we've got the int function, we've also got the string function. We can convert those. We've got the float function as well. What else do we got? User input. All right. I don't remember what that one was, so let's actually look at that. User input. We can construct it. So the input function. So we can construct Python to pause and read data. So we use the input function. All right, let's type that. Input function like that. And then we've also got comments with the hashtag, and that's for added for added information. Let's put it like this: added information to help others understand the code. All right, there we go.
Sentences. And coming up next, we'll talk about conditional execution, where we're really starting to move up to paragraphs. So see you in a bit.
All right, so there's that. I don't think there's anything else right now we can do on that. We'll just type that stuff, and we're going to do this one first. I'll make another one either today or tomorrow of this. I've got this hurricane coming in, so there's probably not going to be like tomorrow. It'll probably be like a couple days because the power is going to go out and there's going to be wind damage, and I don't even know if the roof of this place is going to hold. But we'll see what happens. That being said, we've got all that going on, and so now we're on to exercise 1, and we'll see you next time.